Hello, and welcome to today's lesson. We're in our second units of circles and polygons, lesson 3. Our goals for this lesson is by the end of the lesson, describe and employ the relationship between radius and tangent, and describe and employ the relationship between all tangent segments from a point outside a circle to the circle. Okay, so remember, when we described and defined our terms in the first lesson, we talked about the fact that a tangent and the radius create a 90-degree angle, or they are perpendicular line segments. Okay, the radius and the tangent line are perpendicular values. So now, if we're looking at this situation, we've got tangents at AN, and we've got a tangent at NG. So those tangents make 90-degree angles. So we know that the segments are congruent. We know that the radius values are congruent. And what we've just built here shape-wise is a kite. So everything that we know about kites are true. That the angles connecting the two pairs of congruent segments have to be equal to each other. And the other two angles, since a four-sided shape has to add up to 360 degrees, the opposite angles of E and N are supplementary. Okay, now, when we talk about tangency, we just want to understand that there are a couple types of tangency between circles. We have externally tangent circles where they're tangent at one point, and the circles are outside of each other. And then we have internally tangent circles where they're tangent at the point, but one is an embedded circle inside the other. So now, looking through a few examples here, applying this idea of tangent lines to the radii of a circle, and what can we do overall? We know that this is a 90. We know this is a 90. So worst case scenario, we can work with the entire sum equals 360. But we also want to understand that these two angles are supplementary. So x plus 140 equals 180, and x equals 40 degrees. Looking at another example. Okay, now, in this situation, we have to be very careful. We don't have the radius involved in this situation. So since we don't have the radius involved, we can't call these two angles 90-degree angles. But what we do know is if we're starting from a point and we're connecting to a circle, we know that these lengths are equal to each other. So if we're going through and solving there, we've got a triangle with two equal base angles. So x plus x, or 2x plus 55, equals 180. And then we can just go through. Okay, it's a little early in the morning, so I'm going to use the calculator to make sure I'm getting this one right. Okay, 180 minus 55 equals 125, and that is shared between the two base angles. So we divide by 2 to get each base angle equal to 62.5. Okay, next example here. Toughest example that we have overall. Okay, we do have a bunch of radius values, so we want to remember that their lengths are equal to each other. Very important in this situation. Okay, then we have a radius and a tangent line. We want to remember that those pieces are perpendicular. So we have a 90-degree angle. Okay, and our whole goal in this problem is we're trying to find this measurement of P. Now, we can either do that based on triangles or based on quadrilaterals. And in this case, since this angle is not perfect, we have to work with the quadrilateral. Okay, so we have some help here. We have an outside arc of 78, so that means our central angle is 78. And now all we need left is this angle here, which will allow us to get P. So now, some good news that we have here. We've got some pieces where we're going to be able to find this angle. okay, which will allow us to get the base angles. And once we have these base angles, we can find the missing angle that we need to solve for P. Okay, how can we do that? We have an outside arc of 168, so then we know that Q is 168, and now if, I'm just going to give it a variable name, looking for Z, we know that 78 plus 168 plus Z is going to be equal to 360. So we've got 360 minus 168 minus 78 equals 114. Okay, so we have 114 for the vertex angle, and now we need to find the two base angles of that triangle. Okay, three angles of a triangle add up to 180. So we subtract our vertex angle of 114, not 144. Take what's left, divide it by 2, and we get our base angles of 33 and 33. Now, if my base angle is 33, now I have a linear pair to finish out my quadrilateral. So to get that linear pair, we have to do 180 minus 33. Okay, we've got a 147 angle. And now we finally have everything that we need to get P. So we have P plus 147 plus 90 plus 78 equals 360. Okay, and then we just have to go through, add up the pieces, and subtract out to get our angle measure for P. So we have 360 minus 78 minus 90 minus 147, and we get 45 for that degree measure. Okay, so definitely just some application of some things that we've seen before, adding in one little piece, and that concludes our lesson for today. Thank you and have a great day.